So physics, here we are on experiment 2 for lights and circuits, and these are our instructions, and this is the lab sheet that you're going to fill out. The first set of instructions, and this goes along with the setup that we have here. We're going to use this for the next several labs. It says that we're actually going to skip number 1. We're going to go right to number 2, and number 2 basically is to draw the drawing that you had on your last lab drawing, where you have hooked it up in such a way that you have 2 light bulbs lit. So let's reconstruct that, and here we've got 1 light bulb lit, so let's see if we can get 2 light bulbs lit. So I'm going to connect it here, so electricity goes from here to here, and then I'm going to connect it from there to there, and there we have the 2 light bulbs lit. Now, that drawing here, you should put in here basically the drawing that we had last time for number 5. Number 5, and I clearly made a mistake. So the drawing that you want to make here for the first question, number 2, is the drawing of the 2 light bulbs in series. All right, now, it says, how does the brightness of each of the 2 bulbs compare with the brightness of a single bulb? Well, let's see. So here's the brightness of 2 light bulbs. All I have to do is just connect it right here to see what the brightness is of 1 bulb. So you write down, what do you see as the comparison of the brightness of 2 bulbs compared to 1 bulb? All right, that's number 2, the second part. Number 3, what happens when we unscrew 1 light bulb? So if we have it like this, if I unscrew 1 light bulb, you'll see that they both go out. If I screw it back in, they both go on. I could try this light bulb, and out it goes. So there you have the answer to number 3. Number 4 tells us to design a circuit that will allow us to light all 3 lights, with each one being equally bright. Draw a diagram when you've been successful. Would you characterize it as being in series or parallel? What happens if you unscrew one of the bulbs? Okay, so let's take a look at that situation. I want to try to light all 3. Well, they didn't tell us which way we have to do it, so let's keep on going what we've been doing, and let's connect electricity. So it goes through this one, across to this one, through this one, and then back to this one, and this one is a broken one. Have to get a different circuit board. Okay, here we are working on number 4, and the goal was to set up a circuit that will light all 3 light bulbs, which we did, and the question is whether or not they're series or in parallel. Well, we wired it up in series, so your drawing should look very much like it did in number 2 on this page, or number 5 on the page before, the lab before, except for when you do the drawing, instead of having 2 bulbs in series, we're going to have 3 light bulbs in series. Now, what happens if we unscrew one? Well, just like we did before, if you unscrew one, they all go out. And when we screw it back in, they light back up. Now, you'll notice that they're pretty dim. Pretty dim. And, the reason why they're dim is because we are sharing electricity going across 3 different light bulbs. Now, if I do it in series over 2, we get much brighter. In series with just 1 light bulb, it's the brightest. So we're going to compare this with wiring it a different way in parallel. But one more thing we want to talk about is why if we unscrew these, does the light go out? Well, basically, when we take out the light bulb, we have created something of a switch. And when you disconnect it, that disconnects the whole circuit and no electricity can go through. Number 5 asks us to do a different circuit with 3 bulbs equally bright from dimmer before. So since you're not just discovering it, I'm showing you, we're going to go from series, we're going to switch this to parallel. So let's do that right now. So just to try to be clear, I'm going to wire this with both of them there, and then I'm going to connect this one in parallel with this one, which is what we did in experiment 1. Notice the brightness has stayed the same. It didn't go down. And same thing is going to happen when we connect these two also in parallel. Come on, there we go. There we go. So this drawing will look very much to what we drew in number 4, except for with 3 lights in between. So these are in parallel. And what happens if we unscrew one? Well, if we unscrew one, you notice that the one goes out, but the other 2 stay, and they don't change their brightness at all. And that is number 5. Why? Because, well, we broke the circuit. When we unscrew one, we break the circuit for that part, but the other 2 still have a way to get the electricity around, and so they don't break that. So in your lab, you need to answer these questions as to why. Why does it not turn off the light? Because you said what happens? It turns off the light. Now we're going to say why. Because the one light gets turned off, the other 2 stay on, because the one light broke the circuit, the other 2 lights still have a circuit, and therefore electricity can transfer. All right, number 6. Well, now we want to try to draw a circuit with 2 bulbs of equal brightness and one of a different brightness. Well, how can we do that? Well, we're going to do a combination here of those 2 circuits. So we're going to do partly parallel and partly in series. So I'm going to just clean it up by taking these off. And we're going to bring the electricity into this light bulb. And then we're going to there's 2 ways we could do this. We're going to do this. We run electricity from one into the next. In fact, there's more than 2 ways. And then from here back to the battery, and we can run this in parallel. And you'll see that because there's so much resistance here, that most electricity is dissipated here, and you can't even tell that these light bulbs are on because this guy's so bright, but they're actually barely on. In fact, if I disconnect it, if I were to unscrew both of these, you'll see that the whole system goes out. But if I screw them in, why, that one's still on, even though it's not bright enough to make those filaments bright. So the drawing of our circuit should be a combination of a series and parallel. And I'm not going to draw it for you. I want you to draw it. The first one is by itself, then it goes and it splits into 2 different light bulbs and then goes back to the battery circuit. So draw that there for number 6. And you saw what happens if different light bulbs are unscrewed. If I unscrew the light bulb that's in series, the whole thing goes out. If I keep it screwed in and unscrew one of these, well, there's still a way for electricity to go, but now these 2 are in series. And if I unscrew both of these 2, the whole thing goes out, because now I've broken the parallel circuit. If I keep one screwed in, the other one is lit up. But if I keep them all three screwed in, they all light up, even though you can't quite see these two. These are lit just so faintly you can't see them. Otherwise, electricity wouldn't be going at all. There would be no light bulb. Okay. Number 8. What happens to the brightness when the batteries, this is talking about the batteries, are wired in series? All right, so we're going to look at wiring the batteries up in various different configurations. And the first one is that we're going to do it in series. And what happens to the light bulb when we do it in series? That means if I go from this battery to this battery, and then from this battery terminal back to the light, and you will see that we get a very bright light. So for number 8, we get a nice bright light. What happens if I change the wiring to parallel? So I'm going to take this out, and we're going to put let's see, we're going to go from here, and from here to here, and from here to here, so that both batteries are contributing to the negative terminal. And you'll see that when I connect these two, the battery is just as bright as if I went to just one battery. And I disconnect this. It's the same brightness as if I had just used one battery. It doesn't help me to use two batteries in this way. So when I have batteries in parallel, that's like having two lakes of water the same height. There's more water, there's more electricity stored, but I don't get any more voltage. I don't get any more push. Whereas if the batteries are wired in series, that's like having one lake feeding another lake that's higher, and so with the higher lake we get more voltage. In this case we get the same amount of electricity available, but we've just made one lake or battery higher than the other one, so the voltage gets added, so we get 3 volts instead of just 1.5. With the batteries in parallel, we get the voltage of only 1.5 volts, and so the light bulb is dimmer. In fact, the way I've done it is so much dimmer. There we go. It's dimmer because the voltage is still 1.5. Now this will last a lot longer because we're not using as much electricity and we're drawing out of the same lake. Okay, the last thing asks us to put, what happens if we put the connectors on the same terminals. So let's say that I put this one on the negative terminal here. What happens? Nothing. Nothing. I could connect these two here. Still nothing. Why? Because that's like connecting your pipe to the ocean. You're already at the bottom, so there's nowhere for the electricity to go, and you don't get any current. So the effect on brightness is it is dark. The light doesn't shine. Okay, our last question, number 11, says we're going to use the rotating knob of the potentiometer and see what happens. So the potentiometer is a resistor, kind of like a light bulb, except for this resistor we can change. We can't change the resistance of a light bulb. It's set, it's permanent. But what happens if we connect this? Right now, we've got the resistance down to almost nothing. So the light bulb shines really good because we have these two resistors in series. But if I increase the resistance of this one, resistance gets so great that we don't even see any light coming from it. So we can change the resistance and change how much brightness by the resistance here. And you can buy light switches for your house like this And if you want it not to be so bright in the house, you can turn it down. Or maybe you have a fan on it or something like this that you want to change the speed on. Well, you can use a potentiometer to change that brightness. And this is often used in like our auditorium, Baker Chapel. Sometimes we want the lights a little dimmer, we'll turn them down. Sometimes quite a bit of heat can be generated in here, so some of them actually have internal fans if it's a lot of electricity. All right, now, there's one more thing it asks that isn't written on here, and that is, can we devise another way to hook up two lights than we did in number 6? So let's see if we can do that. Let's hook up, I should say, 3 lights and have a different brightness. So we're going to hook up our battery just to get enough light from it. We're going to hook it up into series, and then we're going to hook up our light bulbs. I'm going to hook up the first 2 in so these 2 are going to be in series and in parallel with this one. So let's see what happens. So right now it's the same brightness. All right, so here we have it set up so that the electricity comes to this light bulb and can go through this light bulb and back to the battery, or it can go onto these 2 light bulbs. But when it goes to these 2 light bulbs, it has to go through this light bulb and then to this light bulb and then back to the battery. So this is a parallel circuit of 1 parallel to 2. So I want you to draw this drawing on the bottom of your paper. So it should look like something like this. You have a circuit that can go like this, and over here we're going to get 2 going back to the battery. So here's a light bulb, here's a light bulb, and here's a light bulb. So the one light bulb is in parallel with the 2 others. You'll notice that if I undo one of these 2, they go out, because when you take out a light bulb in series, the other one can't be showing. But it doesn't take out this one, because the electricity can still go through here even if you turn this one off. And if I turn this one off by unscrewing him, and we cut this guy out, why, the electricity still can go this way, and these 2 are lit. Notice they're not any brighter or darker whether we screw things in, turn them on or off, because the same amount of electricity is allowed to go this way as is to go that way. All right, this is the drawing that I want you to include on the bottom of your lab paper. All right, thank you very much.